Hello, I hope you're doing well. In this video, I want to talk about the top part of Jugglebot. So this is the part that actually catches and throws the ball. So here we can see a CAD model of the entirety of Jugglebot, consisting of the 6 legs that make up the steward platform of Jugglebot. And I covered these in a very detailed video titled How to Design a Linear Actuator. And in this video, I want to talk about this top part here. So in a close-up, this is what this looks like. And just to recap, this has the objective of catching the ball. So when the ball comes in, it will land in this little cup part. This will slide down, and this whole thing will move around however it needs to orient the ball in space. And then when it's time to throw, this will shoot back up and release the ball. So now in this video, I want to talk about how I ended up with this design and why everything is shaped the way that it is. Because it might seem a little bit arbitrary, and it is a little bit, but I've been pretty careful with making sure everything is the correct size and shape to not have any interferences. So let's get into it. I think the first thing to understand with this design is how it differs from my previous design. If you've seen my previous videos, you would recognize this, where I have the steward platform being the blue and green parts, and this orange part with the cables attached to it is the old design for what this video is about. And this worked by having the cables all be pulled tight, and that would throw this orange part up, which would release the ball. Now this is quite good at throwing the ball up, but when it came time to pull this orange part back down again, it had no way of doing that. It was just relying on gravity to pull it down. And I wasn't too happy with that. That didn't seem like a reliable way to bring the hand back down again. So what I wanted to do instead to improve upon this is to have some way to actively pull that, in this case the orange part, back down again so that we can have a fully defined motion throughout the entire path of the ball being held. This might seem relatively easy, we just need some way to pull this back down again. But unfortunately, it's not as easy as it seems, and I could not think of a nice, small, compact way to do this. And that's where this whole big frame thing comes in. When I was trying to figure out ways to do this, I came up with a whole bunch of different ideas. For example, having a string that attaches to the bottom of this cup part and then attaches to a motor on the ground or to a spring or something like that, and that can keep a constant tension pulling this down. But I'm not convinced that that would work, because once this platform moves off on some angle, then the string is not going to be pulling the cup in the correct direction. I need to make sure that this cup part is pulled perfectly orthogonal to this platform, which means that if the platform is here, I need the cup to be pulled straight down. If the platform is here, I need the cup to be pulled out at this angle here. And that's a little bit easier said than done. This is the best design I could think of that could do that, and I am very open to ideas if anyone has any other for how to do this, because I think this design is cool, but I'm not super satisfied with it. It doesn't sit quite right with me. But let's put that aside for now, and let's get into how this actually works. So at the end of the day, all we really need to be able to throw the ball up and then pull the carrier part back down again is this section here. This part just has the cup on the rails, and it can slide up and down, and that's all that we really need, with just a spring or something to pull this part back down to here, and done. That's it. So I should, in theory, be able to just attach that directly to the steward platform part and be away with it, and that's it. So you might be wondering why I have this whole frame structure around it, and particularly why this level up here is elevated from down here. Well, the reason for that is because when this is down the bottom, these rods stick out quite a lot, and this whole structure is quite large. And so when this is inside the steward platform, it can very easily lead to collisions with the legs of the steward platform. To help me design around this and to sort of visualize what's going on, I made a sort of low cost model of what's going on here, and this way I can move everything around and see when collisions occur, and test different dimensions and test everything out. For anyone using Solidworks, a really helpful way to do this is in the assembly menu. You can go into move component, and you can actually have a collision detection setting. So you can select all of the components that you want to check, So let's say I want to check all of these. Then I can click resume drag, and I can drag this around, and as soon as something collides, the model will stop. It will stop moving, and it will tell me that it'll highlight the parts that have collided with each other. This is really, really, really helpful for testing these sorts of models and seeing what geometries work. And so here we can see pretty clearly that this geometry is not going to be able to achieve very much because they collide with very little movement. So what I can do is I can go in this model, I can change the position of the top part. So let's say I can make it a little bit higher up now. So now it's up there. And then I can do the same thing. And so we can see now with this new design where the top part has been elevated, this can now move quite a bit more freely without any collisions. It can take a little while to triple check that you've actually covered all cases because it's a little bit tedious to swap between rotating and moving the different components. But once you sort of get familiar with it, it's not too slow and you can get through it pretty quickly. So after working through this, I figured out what geometry I needed and how high I needed this upper part to be from the platform so that there were no collisions between any of these rods or pieces down here with any of the legs. And with that, I was good to go. Before we go any further, I just want to preemptively address a question that you might be having, which is that why don't I make this space up here larger? Which is to say that I can just have a larger area that the ball can potentially fall into and not collide with any of the other parts. And the reason for that is because the larger that this top section is, the further apart these three guide rods need to be. And what that means is that these rods here would need to be even longer than they are now. So for example, if this block that supports this guide rod was all the way out here, then these two rods over here would need to be out to about here also. They would need to be quite a bit longer than they are now, which is fine, except for when this moves down, these rods are now sticking out really far and are very prone to colliding with the legs because it's just so many rods in such a small amount of space. So that is why this is the size that it is. And it would be nice if I could make it a lot bigger and have a larger sort of catchment area, but I couldn't think of a good way to do that. So this is what it is right now. I think that this should still be fine as it is. But if I find that I need a larger catchment area to account for errors, then I'll cross that bridge when I come to it. So working through both of these design considerations, being the height of the top part, and the second consideration being the catchment area that I just talked about, working with both of those led me to this design that you saw before. So that describes the geometry of this space frame part with all of these carbon fiber tubes. And now I want to go on to these pulleys and what they are doing. Briefly, there will be a cable that will come from this hook here and wrap over this large pulley. And then on the smaller side of the pulley, there'll be a cable that will go down to a motor on the ground. The reason why this pulley is stepped like this, I covered in an earlier video, and I'll put a link to that on the screen now in case you're interested. But the TLDR is basically just for mechanical advantage, to make sure that this slider can move really quickly even when the platform itself is not. What I want to cover now though is this little hook in here, because it serves a pretty important role. And what that role is it ensures that even when the platform is up at some angle like this, the cable that goes from the motor down on the ground up to this pulley is routed nicely over this pulley so that it will coil properly. If I didn't have this guide hook here, then what would happen is when the platform is off on an angle, the cable will just run straight from this pulley and then it will try to go straight down to the motor and it will rub on this other pulley or somewhere else and it will just not coil nicely. So this hook, in theory, should stop that from happening and should allow it to coil nicely. As for the rest of the structure, it's relatively straightforward, to be honest. These carbon fiber rods just push into the printed parts and they are very, very solidly in there. I don't think I'll be able to pull them out anytime soon. These hooks down here are for strings to attach. I put them there just in case the rigidity of the space frame is not enough on its own to withstand the forces involved, and in case everything started to flex out a little bit. So if I do notice that when I'm using this that these parts tend to flex out from each other, then I'll put some strings in here to tie the two sections together and hold them all nice and tight. There is one thing that I'm missing on this CAD model though, and that is the mechanism to return this back down again, which is the whole point of this structure, is to help this return back down. I am planning on using some constant force springs, but I just haven't had time yet to include them in this model and to actually test that idea out. So I'll hopefully be doing that sometime soon. So that's the theory of what this design is. And now we can actually look at it in practice, because over the last couple of weeks, I've been printing all of the parts for this and putting it all together. And in my opinion, it looks pretty nice. But there's a pretty big problem with it, which is that as it is right now, this carrier sticks quite a lot on the rods when it's sliding up and down. Now, I don't have any bearings in these joints in here. It's just the 3D printed part against the metal. So having bearings on there would absolutely solve the problem. But bearings are quite large, and I don't really want to put 9 of them on here, because that size and weight is just going to make this whole thing a lot more bulky, and I want to try to avoid that if possible. What I have noticed though, in just playing around with this, is that if I push these 3 carriers in, then the whole thing slides up quite smoothly and back down again. It's just a little bit awkward to hold. So I think that once I add in those constant force springs or other springs, hopefully that will fix this problem. I'm not fully convinced that it will though, and any amount of sticking on these rods is honestly going to be too much. This needs to slide very, very smoothly to receive and throw the ball in a smooth manner. So I'll have to see how this goes. As for the rigidity though, this is very, very solid. It's a super, super solid frame, and it's quite light given how big it is. So I'm very happy with how the space frame side of this worked, but I'm a little bit less convinced about the actual catching and throwing bit. So we'll see. So that should hopefully give you a pretty good idea of what this component is doing and why it is the way that it is. And if you have any ideas about any of this, then please let me know. Particularly if you have any ideas of how to stop this binding motion where it's getting stuck. I would love to hear. This is sort of irking me, and I would love if I could fix this. One other thing that I do want to add is that it seems like this has very little room for error, because there's so much space for the ball to go that is not on that cup. However, I think that the legs should be more than accurate enough to land the ball precisely in the center here. And if it's not, then I have ideas of how to add some panels on these faces here to sort of guide the ball into the cup, even if there's a little bit of inaccuracy. So even though in theory the ball could escape the cup and not land perfectly in place, I do think that's a solvable problem. And honestly, I don't think that problem will happen at all in the first place. Fingers crossed. Yeah, so that's it for this design. I hope that was interesting for you, and I'll see you in the next video. Have a good one. Further before bodies start to collide. Oops.